All right, in this section, we're going to look at how interest is actually computed in real life. This is referred to as compound interest. So if interest is paid on both the deposit and the interest, we have compound interest. So compound interest refers to when interest is actually computed, and it's usually done on a specific date throughout the year. So let me do an example where we do it monthly. So suppose you deposit $1,000 into a savings account that pays 12% APR. Now I use that number just to make the numbers that I'm going to do next easier. There's no way you're getting 12% interest. That's way too high. But nonetheless, it'll illustrate what I'm talking about. Assume we compute interest monthly. So that's 12 times per year. So basically at the end of each month we will start computing the interest, and then at the end of the next month we'll compute interest again, etc. So I've got my APR and I've got my compounding. So let's keep track of this. Let's take a look at after the first month and etc. So after and then we'll call it amount for the account value. So let's say start with 0 months. You're going to have your initial deposit, of course. Now 1 month, here's how the interest works for this. We're going to take our $1,000 and we're going to multiply it by 1 plus RT, just like we do for simple interest. Now though, T is just 1 month, so I have to specify it in terms of a year. This is equal to 1,000 times 1 plus, the R was 0.12 and the T was 1/12 of a year. Let me write this in a form that is more usual to us, and it's the form that the formula will come in anyway, so I might as well write it. So there's my principal amount. I have my rate up there, and then down there I have the number of months, the 12. Now let's go on 2 months. Now the way it works is they pretend that the amount that you have in the bank after the first month draws interest, the whole amount, not just the principal. So you take the entire amount that you have. So I take my amount that I had from before, 1,000 times 1 plus 0.12 over 12, and I do it again. So I multiply that by 1 plus 0.12 over 12. And if I simplify a little bit, you can see that I'll get, let me get my 1,000 in there. You can see that I'll get 1,000 times 1 plus 0.12 over 12 squared. So hopefully you can see the pattern now. If I do 3 months, we have 1,000 times 1 plus 0.12 divided by 12 to the third power. And if we keep going on, I'll put dots to indicate that. Let's see how much he has after a full year. After 12 months, we're going to have $1,000 times 1 plus 0.12 divided by 12 to the 12th power. And now let me go ahead and figure that out. I get approximately 1126.83. I'm only going to 2 decimal places because we are talking about dollars and cents. Now, before I go on with more examples to illustrate this method, let me show you how much you would have made if you would have put this into a simple interest account. So suppose you deposit $1,000 into a simple interest account, paying 12% APR. So under that situation, here's what we get for our total amount. I'll have my $1,000. Remember, the formula is P times 1 plus RT. So I have 1,000 times 1 plus 0.12 times 1. So this will be 1,000 times 1.12. All I have to do is move the decimal place over 3 places, and I'll have $1120.00. So you can see that the compound interest was more. I made more than $6 doing that. Now, what if you did it for a bunch of years? So let's take a look at that. If we do compound interest, let's say we have the 1,000 times 1 plus 0.12 over 12 to the 12th. That's after 12 months. We can keep going. After 24 months, how much do we have? We have 1,000 times 1 plus 0.12 divided by 12 to the 24. And let's see how much that is, roughly speaking. Here, I get 1269.73. Now, if we consider that in regards to simple interest, so let me do this. For that, 24 months is 2 years. So the amount that you're going to have in the simple interest case will look like this. And that's going to equal $1,000 times 1.24. So that equals 1,240. So you can see now we're $29 up. Now let's continue on for 30 years. So that's 360 months. After 360 months, let's take a look at how much we have in compound formula. We have the $1,000 times 1 plus 0.12 divided by 12, but they're going to have 360 up in the numerator. I should have said 360 into the exponent. This is approximately equal to 35949.64. Now let's compare that with simple. Here you're going to have 1,000. Remember, this is 30 years, so it'll look like 0.12 times 30. So that'll be 1,000 times 1 plus, what is that going to be? 3.6. So that'll equal 1,000 times 4.6, and then I'll go ahead and move the decimal over, 4600. And let's take a look. 4,600 versus 35,000. So hopefully you know that people use this kind of interest for long-term savings. So this is the kind of stuff that will affect retirements and payments on houses, things of that nature. In the very short term of like a month or something, they're not much different. But in the long run, compound interest is way more powerful than simple interest. All right, let me get the compound interest formula, and then we'll do some examples. And it looks like this. I have the amount is equal to the principal times 1 plus R divided by N times NT. What are all these symbols? We've already done this. A is the account value. P is the principal. R is the APR, the annual percentage rate. N equals the number of compoundings per year. And T equals the number of years. All right, so we'll exploit this formula as we do some of the problems. I also intend to do some examples to show you how to enter it into your calculator. As a first example, let me redo the example I did, but under different compounding schemes. So suppose you deposit $1,000 into a savings account that pays 12% APR compounded, and I'll put 3 dots because I want to do several examples at once. So we'll do compounded yearly. I did monthly. Compounded quarterly. And compounded daily. How much will we have after a year? And we'll use the formula throughout. So let's see what information we are given. Let me write down the formula first of all. A equals P times 1 plus R over N to the NT. A is the amount that I'm actually trying to figure out, so I'll put a question mark next to that. P, there is our $1,000. R that will equal 0.12. And then n and t, well, t is equal to 1, and then n vary depending on the problem. So we'll start with part A, and I have every letter then I need except for the letter A. So A will equal the 1,000 times 1 plus 0.12 divided by, now for part A that was yearly, so we're going to do it once per year. That means the n will be 1, and after 1 year the t will also be 1. So you can do a little bit of simplifying, but let me make a caution to you. Don't go too far in simplifying. Let your calculator handle this. So this will be 1120. So after 1 year, under this compounding scheme, we'll have $1,120. Let's go next to B. This time we are going to be doing it quarterly. That's 4 times a year. So A will equal 1,000 times 1 plus 0.12 divided by 4. So that's 4 times 1. N is 4, T is 1. This is 1,000 times 1 plus 0.12 divided by 4 to the 4. You're not expected to do any of these computations by hand. All of them have large exponents usually, and it's impossible to expect you to do them by hand. So typically I won't do any simplifying. I'll just let my calculator do all the work. Here I get 1125.51. So we have $1,125.51. You can see that it's a little bit more than part A. So the more times you compound, the more money you get. Now, what is probably the most usual case, before I finish here, let me do this. N equals 1, N equals 4, and for C, N will equal 365 because we're doing it daily. This is the most usual case nowadays. Everything is computed daily. Any interest that you have to pay is computed daily. The amount here, then we're going to get 1,000 times 1 plus 0.12 divided by 365 to the 365 times 1. The only real simplifying I'm going to do is just to simplify the exponent. And let my calculator do the work. Here I get 1127.47. And so the total amount here is 1127.47. And you see that daily will give us the most for our money. And that's as far as you're ever going to be able to go. And you can see that after a while it does reach a system of diminishing returns, because if you try to compound more, you don't really gain a lot more. Daily is kind of as big as it gets. All right, next, suppose you deposit $5,000 into an account that pays 5% APR. How much will the account be worth after 10 years if the interest is paid? So let's write down the possibilities here. Let's say yearly. Remember, that's the least advantageous. Quarterly. monthly, daily. What I'm going to do is I'm going to do this example in total and get the numbers and everything like that, and then we're going to try to show you I am going to try to show you how to enter these things into your calculator. All right, so let's start. First of all, let me write down all the information that I know. A is the thing that we're always going to be trying to figure out. P is the 5,000. R equals a 0.03. N, that will vary. And then T equals 10 years. So for part A, when I say yearly, I mean that N equals 1. And so my formula looks like A equals P times 1 plus R over N to the NT. Let me go ahead and put in all of my numbers. 5,000 for P, 0.03 for R, N was 1, then 1 times 10. T is equal to 10 for all these problems. I'll simplify just a little bit and let my calculator compute this. Here I get 6719.58. And that takes care of yearly. Remember, my numbers should get higher as I go along this, so that's one way that you can check to see if you're doing things correctly. For part B, that was quarterly, so N is equal to 4. So A equals 5,000 times 1 plus 0.03 divided by 4 up to the exponent 4 times 10. It's a good idea to simplify the exponent. That's something that's easy enough to do usually. And let your calculator do the rest. So here we have 6,741.74. And you can see that's quite a bit more than for part A. Now as we go to the next one, which is monthly, you're going to see that the jump is going to be, it's going to go up, but not as much as it did the first time. So here we'll have A equals 5,000 times 1 plus 0.03 over 4 to the 4, I'm doing 12, so let me change that to a 12. 12 to the 12 times 10. A little bit of simplifying, 5,000 times 1 plus 0.03 over 12 to the 120. Once again, a little bit higher than before, 6746.77, but not as big of a jump as before that. And finally, the last one, this will give us our biggest amount, N equals 365. Whenever you're given any of these problems in my class to do, always use 365. Don't worry about leap years. We'll just pretend they don't exist. So for this, in real life though, leap years are accounted for when they do interest. 1 plus 0.03 over 365 to the 365 times 10. And I'll rewrite that as 5,000 times 1 plus 0.03 over 365 to the 3,650th. Here we get 6749.21. And you can see that's just a little bit more than what we had for monthly. Now what I would like to do is redo this whole example, but using the calculators. Now I'm going to do it 3 times. I have 3 different types of calculators, and the ones that I use are, I think, the most popular kind, so I should be able to cover everything because the inputs are really what's important, how you input the information. We're going to start with a graphing calculator. And keep in mind, I do not in any way, shape, or form recommend that you get a graphing calculator for this course, but those calculators are very capable of doing these problems very easily. You'll see what I'm talking about. Let me pull up my calculator. Let me clear it out. And I'll have that thing around as I do these problems. I'm going to start with part A again. And that was where n was equal to 1. And what we had was the formula A was equal to 5,000 times 1 plus 0.03 divided by 1 to the 1 times 10. So all I really have to do, watch how closely it mimics the look of the problem. I don't have to put a times or anything. I can start a parenthesis and do 1 plus 0.03 divided by 1. You don't have to do that part, but I'm just doing it to show you this calculator can handle it. Then this button right here, this little caret button takes you up into the exponent. Did you see the cursor shifted up? Now up there you can do 1 times 10. You don't have to bother simplifying it yourself. You can let the calculator do absolutely everything. And you can see I get my 6719.58. These should, of course, be the same as the number that I got before. Now, when n was equal to 4, here we had an exponent of 4 times 10, so I can enter it just like that. So I'll do, and there's another cool thing about these too. I can actually come up here like this and hit enter, and it will let me edit it. So I can backspace over here where that was, and I can put a 4 there, and I can backspace down until you get to there, and I could have hit a 4, and then just hit enter. I didn't see what all the digits were. 6741.74. So I'm rounding to 2 decimal places for each case here. Here n was equal to 12, so our formula looked like A equals 5,000 times 1 plus 0.03 divided by 12 to the 12 times 10. Now, inside of the parentheses, do not in any way, shape, or form get the idea that simplifying is a good idea. If you simplify or try to round the decimals inside of this parentheses, your answers will be wildly inaccurate. Do not in any way, shape, or form simplify inside the parentheses. All right, then I need to get into the exponent. And here I'm going to put 12 times 10. So there's no, the graphing calculator provides us with by far the easiest way to do these things. 6746.77. And then finally, n equal to 365. My A will look like 5,000 times 1 plus 0.03 divided by 365 to the 365 times 10. So I got my 5,000, then I have 1 plus 0.03 3 divided by 365, and then I will raise that to 365 times 10. And then when you hit enter, it'll give you your answer. So here I get approximately 6749 point, what was it, 21? Let me compare my numbers from before just to make sure that they came out to be exactly the same numbers. 74 and 58. So all of those decimals are exactly the same as before. And that's how you do it with the graphing calculator. Next, I'm going to work on a calculator that has a multi-line display. And I'm going to redo all the examples as before. So let's redo the last example. And of course, to remind us, here we had P was equal to 5,000, R was equal to 0.03, T was equal to 10, N varies, and the amount was the thing we were trying to figure out each time. So for this, I'm going to have to invoke my calculator or my computer's camera because I don't have an emulator for these other kinds of calculators. All right, this calculator that we have here, the Texas Instruments TI-30X IIS, is sold on campus. It's also sold at every store that I've ever been to. So it's not hard to find. It's a pretty cheap calculator, and most students opt for this type of calculator in the class. Let me turn it on. Now, it may jiggle around as I go and do things, but hopefully you'll be able to see everything. Let me clear everything from here. We're going to redo that example. So for the first part was finding out how much money we had when we compounded only one time per year. It looked like this. We had $5,000, so let me go ahead and put those numbers in. Then you can start a parenthesis, and then we can do 1 plus 0.03 divided by 1. Finish the parenthesis, and now we need to do the exponent. So here we have a caret button for that, like so. And then if you remember, the exponent was 1 times 10. So you can just put 10 up there, or if you don't want to do the computation yourself, you need to put in parentheses 1 times 10. And then you hit equals, and you can see that it gives us the same number. Now, as we go through the problem, to redo the problem, but for n equals 4, you can hit the up arrow key, and it will let you edit what you have. So the only thing I had to do here was change the 1s into a 4. See if I could, it's difficult to do when the calculator is in front of the camera. And then I'll go over to here. Here I had 1 times 10, so let me change that 1 to a 4. And now I'll hit enter. And you can see these are the same numbers I was getting from before. Up arrow. Now if I want to do it for 12, I'll change that 4 to a 12. The only problem with it is, watch what happens when I change the 4 to a 12. I'll do 1, 2, But you see, it'll overwrite. It overwrote my parenthesis. So I got to put my parenthesis in again. Uh-oh. When you do that, it's best just to clear it all out. Hit clear. Start over. 5,000 times 1 plus 0.03. This time it was divided by 12. Finish the parenthesis. Now to do everything in the exponent, put it also in parentheses and do your 12 times 10. Finish the parenthesis and you hit equals. Hopefully you can see that these numbers are exactly the same as we were getting before. Up arrow. The last case was daily, so I need to change that 12 to a 365. And as before, it's going to overwrite what you do. So I have to refinish the parenthesis, exponent. Here we'll do 365 times 10. Finish the parenthesis and equals. And I'm noticing these are exactly the same numbers that we got before. Now, let me move on to what is perhaps the most basic calculator of all, that what's called a single line display. If I want to redo these problems, I'm kind of stuck working my way inside out. You can try to do it directly. I'll try to do 5,000. Now, I don't know if you need to put a times, but I'm going to put a times. And then I'm going to start a parenthesis. See how it's got it there? Now, inside the parenthesis, I'm going to do 1 plus 0.03 divided by 4. And then when I hit equals, I'm not exactly sure what that is. Let's try again. 5,000 times, let me start a parenthesis, 1 plus 0.03 divided by 1. Finish the parenthesis, and it tells you what you have inside of the parentheses. Now I have to take it to an exponent. In the case of yearly compounding, the exponent was simply 10. So I look for this x to the y button, I hit that, and then I put a 10. Oh, by the way, if you hit a wrong digit like I did, hit the C button, not AC, just C, and it will let you correct that. So I can put my 10 in. And now we can hit equals and see what we get. So there I get the 6. I matched the first number that I got before. Now let's try it for quarterly. I'll do the same thing as before, 5,000. And then I will do times. I will start a parenthesis. I will go 1 plus 0.03 divided by 4. And let me finish the parenthesis. That's what's inside of the parenthesis. Now I have to take it to the 4 times 10 power. I recommend working that out in advance to 40. And then because parenthesis use on calculators like this is very dicey. So I'm going to hit x to the y, and I'm going to put a 40 up there. And once again, I made a mistake on the button, so let me clear that and put my 40 equals. And you can see I get my 6741.74 like I got before. Let me clear it. After that, we did monthly. So that's going to look like 5,000 and then times, I don't know if you need that times, but I'm putting it in parentheses. I'm putting it before the parentheses just to be on the safe side. I'll have 1 plus 0.03 divided by 4, finish the parenthesis, that's what's inside of it. Oh, you know what, I did the wrong example. Let me start over, I'll do all clear. 5,000 times 1 plus 0.03 divided by 12, finish the parenthesis, that's what's inside the parentheses. Now 12 times 10 was equal to 120. So now I have to take that, raise it, so take it to the exponent. 1, 2, 0, and then finally hit equals for your answer. 6746.77. And then for daily, let me finish off this example. I'm going to try it without the times and see what happens. It didn't complain, so 1 plus 0.03 divided by 365, finish the parenthesis. Now this is what I was talking about. Your calculator here, if you look at it, it looks like I have 9 decimal places of accuracy. That's way more decimals than you would ever carry if you were going to do the problem by any means, where you simplify inside of the parentheses. Not only that, the calculator keeps extra digits inside of it that are beyond the ones you see here. So its accuracy is a lot more than what you're capable of doing. So let me again reiterate, do not simplify inside the parentheses. Let your calculator do its job. Now I need to raise that to, it was, n was 365, so you had 365 times 10, so that's 3,650. So I'll hit the x to the y, and then I'll put 3650 equals, and well, that does not look like what I should have had. I'm not going to have $1.35, so obviously I did something wrong. Let's try again. 5,000. It probably did not like the fact that I did not do the times. Now I will do the times, parenthesis, 1 plus 0.03 divided by 365, finish the parenthesis. I am going to raise that to the 3650 power and see what we get for our answer. And you can see I get my 6749.21. So yeah, any way you do it, you pick your calculator, whatever you do, don't pick the old 4-function calculators. Use some sort of at least a scientific calculator, and I highly recommend using ones that have multiple display lines, like I just used on my, like I used on the TI-30.